Okay, welcome to my video on uh, programming with the TI-84 system calculator with systems of two linear equations. Here you can see with the TI Smart View, I have the calculator turned on, and you can check that you're in calculator mode by entering an expression such as 9 times 9 and enter, and the calculator says 81. For this video, we're going to learn how to graph systems of two equations. And if you remember from the previous video, you click y equals to enter your list of equations. Here, the first equation listed is 3x plus 1. For the second equation, I'm going to type in, say, negative 2x plus 7. So my key history for the calculator is down below. And so you can see both equations here. In order for you to see that on the graph, we'll click the graph button, and the second equation is graphed in red. Here, I'll refresh the windows on the right. So as you can see here on the list of equations, we have the first equation is the blue equation. It's colored blue there. On the left, you can actually change the color settings, and it's represented on the graph in blue. The second equation is coded in red, so you can see that this one with the -2 slope is graphed in red. Also, if we go to the table down below, here I'll change the table settings so that they're reset to start at 0 with its normal scrolling settings on auto. So when we go to the table, you'll see on the left side that you can scroll positive or negative. Here it's at -5. You can get the values for both the blue and red equations. You can compare how far apart they are. So for example, with a lot of the word problems, they want to know either the difference of the two different equations, equation A versus equation B. They want to know the difference, or when the two equations are the same. So by scrolling up and down on the scroll bar, you can easily compare the integer values. But if we look here, we can see that, well, the equations look like they're very close to each other here at x equals 1. However, the problem is that they're still 1 unit apart. So wherever the intersection is, it's close to 1 on the graph, but it's not exactly at 1. So to find the intersection point using the Texas Instruments calculator, we're going to use one of their the calculator's commands. So what we'll do is we'll hit clear the screen so you can see these coding blocks. You hit second trace, and then this pop-up menu comes up with 7 different commands. Here we want to find the intersection of the two functions that we typed. So hit enter for command 5, and then it goes to the same graph, but now it's highlighting the blue line y1 equals 3x plus 1, and it has this little butterfly or quadcopter like drone that's attached to the function line. It's a straight line. So by going left and right with these controller arrows, you can move along the path of the rule 3x plus 1. So what you want to do is you want to go near the intersection point. You don't have to be right on it. Here I'll go to, like as I said, it was near 1. Here I'm at 0.9. Hit enter. The calculator then will switch to the second line. If you have more than 2 lines, you can switch back and forth, as you can see here, by clicking up or down. So we're on the blue line, but now we want to use the red line. So now if I move left and right, the little drone is, for the second curve, want it to be near the intersection. So again, I'll choose a value a little bit bigger to the right of the intersection, maybe at like 2. It's close enough as long as it's in the general area of the intersection point. You'll see that the Texas Instruments calculator is really good. As long as like I'm within that blue circle of area, it will find the common intersection with the two functions. So here we go. Hit enter and it'll lock the drone in place. It'll say guess, hit enter again. And it'll tell you that the intersection is precisely at X equals 1.2 comma 4.6. That is the solution to the system. So since it's intense, as I mentioned before, well, we didn't know that when we calculated the intersection. However, we can do the table setting of the window, and we can change the table step, this triangle table, the change step, to 0.1 again, because that was intense. Then when we go back to the table scroll, we can scroll down to let's see, 0. When we get to 1, you can see that the values of the function are getting closer. But at 1.2, here we have the exact intersection. Both the blue line and the Y line have height of 4.6. We can also confirm this with the second table setting option here. Again, I'll just reset it to 1, and I'll reset the table start to 0, which are the defaults. And then I'll change the independent to ask. So we can confirm our answers by then going to the table, and it's blank on the left. So if we enter 0, it'll give us the value of both functions, 1, but we can also enter decimals, 1.20. And here it shows that 1.2 is the true solution once again. As you can see, it shows that both function 1 and function 2 have an output of 4.6. So this is very useful for graphing systems of linear equations. I hope this tutorial on the Texas Instruments 84 has been useful to your studying and prep for the SAT. Thank you for watching my video.